So here is an image that I found online, and it talks about solids. And you see how the molecules, so the atoms are all close together and tightly packed. This is rigid. It is a fixed shape, like your rock. That rock is not going to change its shape. It's and a fixed volume. That means the volume will not change. It cannot be squashed. Cannot be squashed. Now liquid, you see the particles are a little further apart from each other. They're not so tightly packed. It's not rigid. There is no fixed shape. It can flow into another shape and change into that shape. There is a fixed volume though. The fixed volume, that means that when I pour this glass of water into another glass, it has the same amount of volume, though it has changed shape. It cannot be squashed. I wonder if it can be squished though. Now gas, you see how far apart these particles are? It's not rigid. There is no fixed shape, and there's no fixed volume. And it can be squashed. So liquids and gases are actually classified as fluids. Think about how the particles move. Why do you think liquids and gases are classified as fluids? Don't stare too long. So while solids have a fixed shape, liquids and gases are free-flowing and can easily change shape. A solid will not change shape based on the container it is in, while liquids and gases will. Okay, so you should have your states of matter paper out, and a part of being a scientist is recording and understanding your observations. You made observations at the beginning of the lesson by simply noticing the world around you. Look at the list you made of the things that you observed. Now that we have discussed states of matter, do you notice more things around you that fall into the different states of matter? Remember, you do not have to see your observations to know they are there. For example, you cannot see the air you breathe, but you can feel it. So I want you to complete part 1 by recording the examples of the solids, liquids, or gases that you observed at the beginning of the lesson. I want you to add to your list, but you don't need to fill up the entire list. You don't need to have, 6, but at least have 3 of each, see? So this is solid. This type of matter will have a definite shape and size. Liquid. This type of matter will take the shape of its container, but still have a definite volume. Gas. This type of matter will fill its container and disperse, having no definite size or shape. So I want you to fill this in and then move on. Look at the picture titled States of Matter. This is one of these that I posted on the website, and it's optional for you to print off if you want to. So what do you notice about the shapes of each of the states of matter? So the solid has a definite size, shape, and volume right here. Okay. The gas has no definite size, shape, or volume, and will eventually fill the whole space it is in. The liquid takes the shape of its container, but we can measure its volume. Now look at the circles next to each state of matter. The small round balls drawn inside each circle show a magnified view of the solid, liquid, or gas particles. What do you notice about the particles of each of these states of matter? The solid particles are rigid, right here, and they're stuck together. The liquid particles have a little more space between them, and then the gas particles have the greatest amount of space between them. Both the liquid and the gas state do not have a fixed shape. These guys here. Remember, the tiny particles that make up each of these examples are in constant motion. Looking at this picture, how would you order each state of matter from the highest to the lowest energy level? Gas particles can move freely and quickly and have the highest amount of energy. Liquid particles have a lesser amount of energy than gas particles, but can still slide past each other. Solid particles have the least amount of energy and can only vibrate. Okay, so let's see what else we have. Draw what the particles would look like for each state if you could see them up close. So what would the solid particles look like, which we just looked at them? Liquid particles, what would they look like? And the gas particles. And I also want you to think about what they would look like if you were a particle. So I want you to jump up from your chair right now. I want you to stand up. Just everybody stand up right now. And I want you to pretend that you're a gas particle. Now, if you're a gas particle, you are jumping up and down, running around. You are flipping over things. You're doing all kinds of crazy things. You are jumping. You are crazy. You got lots of energy. You can't stop moving. It's just crazy. It's nuts. Oh my gosh. Okay. Now, if you're a solid, I want you to change to a solid right now. Now, you're not moving very fast. You're not moving at all. You're just vibrating. You're not moving. You're solid. You're just vibrating just a little bit. Okay, now if you're a liquid, well gosh, liquid has a little more space to move. Can run, not run, but you're kind of walking around, chilling, you're moving around. Yeah, hey man, what's going on? How you doing? Oh, I'm doing good. Oh, thanks a lot. Yeah, you're hanging out. You got some space with your friends. You can chill out. Woohoo! You're not just stuck in one spot like a solid. Or you're not bouncing off the walls like a gas. So, for class on Thursday, which is in 2 days, and I apologize, I want you to bring your completed states of matter, and I also want you to bring in your measuring at home page that we talked about last week, and I want you to write down, you measure everybody's feet in your house, your dog's foot, your cat's foot, your mom's foot, your dad's foot, I don't care, everybody's foot, your brothers, your sisters. You are going to put down the person in the family with the largest foot. And then you're going to put down how many centimeters that person's foot is. And if it's the left foot or the right foot, because you have to measure both of them. And I want to see you to be able to see that our feet are not all the same size. And I want you to do the person in your family with the smallest foot. and how many centimeters that foot is. And which one? Is it the left foot or the right foot? The person with the biggest difference in foot size. Now this is for the older kids. Yeah, it's a challenge. If you think you can do it, for the younger kids, if you think you can do this, then I want to see it. I want to see you do it. The person with the biggest difference in foot size. So my son Isaac, his left foot is 27 centimeters and his right foot is 27.5 centimeters. So he only has, okay, it would be 5 millimeters difference, but, or half a centimeter difference. Now my foot, my left foot is 25 centimeters and my right foot is 26 centimeters. So I have a whole centimeter difference. So the person with the biggest difference in foot size between my left and my right is going to be me. Grade 6 plus. I want you to research a little here. If you have time, I know we're cutting it short, but are there other states of matter? And what are they? I want you to bring a list of examples to class on Thursday. I'll see you on Thursday.